Unable to get your app to work, not sure where the error is, frustrated in finding the bugs? Then this video is for you. Today, I'm going to show you the different ways to debug React Native application. Let's catch the bugs. Welcome back to Just Code channel. Please support us by subscribing to our channel and like our video. If you have not watched the last tutorial video, please click on the link provided below. If you have any questions regarding this tutorial, please leave a comment below. Debugging a React Native app can be a pain for beginner to React Native development. Unlike the Microsoft Visual Studio, Android Studio, and Xcode, React Native don't have its own integrated development environment (IDE), and therefore, the debugging feature doesn't come out of the box. In this video, I'm going to show you a few ways that you can debug a React Native apps. The first way is to use the Chrome browser. This is the easiest way. First, ensure your Chrome browser is the default browser in your machine. Let's bring up the terminal screen and launch the React Native app as per normal. Wait till the app launch in the iOS simulator. Select the iOS simulator window and press Command D or Command Ctrl Z to bring up the pop-up menu. Select the debug menu item and the system will launch the Chrome browser and open up the debugger page. In the browser, open up the Developer Tools. In the Developer Tools window, we will focus on the Console and Source tab for the debugging purpose. The Console tab will show all the console log within the app that is generated by your application or the React Native engine. For example, let us bring up the VS Code and open the search index.js file. In the onSearch method, we have performed a console log when the getDemas returns the result. Let's bring up the Chrome console tab again, and on the iOS simulator, key in a word and click on the search button, and we will see the result of the getDemas log in the Chrome console tab. Let's expand the log for the result returned by the getDemas. We can see the JSON object returned by the getDemas. However, just based on the console log to debug an app is not enough. We need to be able to trace the application line by line. To do that, let's change to the Source tab in the Chrome browser. Expand the debugger worker, localhost, and the project folder in the Source tab. We will see the folder and file structure of the app. Let's open up the source screen search folder and double-click on the index.js file. Place a breakpoint on the onUserWordChange method and another breakpoint in the onSearch method just below the try keyword. Now, let us try to type awesome in the simulator text box. When we press the letter A, the breakpoint in onUserWordChange will hit, and we can see the parameter text value. We also can see all variables in the local section on the right of the screen, or add the variable we want to inspect into the watch list. Now, press F8 to continue the execution. Let's remove the breakpoint in onUserWordChange method and finish typing the word awesome. Now, let us click on the search button in the iOS simulator and the breakpoint in onSearch method will hit. Please take note that the onSearch is an asynchronous method. Plus, the React Native will transpile the code, and therefore, the debugger will step into the transpiled code in the bundled JavaScript. Let's press F10 to step over the code, and you will see that the debugger will step into the index.bundle file. The source in this file is generated by the transpounder. Therefore, you might be confused by the source code the debugger displays. In this situation, I would suggest that you press multiple breakpoints and press F8 to continue running the app until the next breakpoint hits. For example, in the onSearch method, if I only concern the code before executing the getDemas and the result returned by the getDemas, then I can place a breakpoint on the console log. Let's click on the search button on the simulator to trigger the first breakpoint. Now, press F8 to jump to the next breakpoint. The second breakpoint will hit without stepping into the index.bundle. Let's press F8 to let the execution continue. Now, open the flavored index.js file. We will try to debug a method that returns a promise. Let's place a breakpoint on the helper.getFlavorList under the loadFlavorList method. Click on the Flavor tab in the simulator and the breakpoint will hit. If we press F10 to step over the current line, we expect that the debugger will jump to the then method block. However, that is not the case. It will straight away jump to the end of the loadFlavorList method, as helper.getFlavorList is an async method that returns a promise. If we press F10 again a few times, you might be confused about the program flow. To step through a method that returns a promise, the best way is to place a breakpoint before the function call and at the first line in the then and catch method block. Now, let's reload the flavor list by toggle the search and flavor tab again in the simulator. The first breakpoint had activated, and we will press F8 to activate the next breakpoint in the then method. We now can see the result returned by the getFlavorList method. Let the application continue to run by press F8 again. You might ask, how do I step into the getFlavorList method? If getFlavorList is a normal method, then pressing F11 in the debugger will do. However, since getFlavorList is an async method that returns a promise, therefore, we need to set a breakpoint in the helper.getFlavorList method. Let's open the helper.js file and place a breakpoint in the getFlavorList method. Let's reload the flavor list again. Now, we will press F8 again, and the debugger will hit the breakpoint in the getFlavorList method. If I want to see the result returned by the async storage.getItem, then I need to place another breakpoint just below the async storage.getItem method and press F8. The flavored list string variable will contain the JSON string for the flavored list. Let's press F8 again, and we will return to the coder then method block. Till now, what I am trying to show is the special behavior of async method in the debugger and how we overcome it. Next, I'm going to show you how to perform debugging in VS Code. Before we proceed, we need to queue the app in the simulator. Next, we will close the Chrome browser, followed by terminate the macro bundle in the terminal screen. Now, bring out the VS Code with the project folder open. Make sure you have the React Native Tool extension installed in the VS Code. To check is the extension installed, click on the extension icon on the left and key in React Native in the search bar. Click on the React Native tool item and you will see the installation status. If not yet installed, just click on the install button. Now, Close the extension window and all other source code windows, if any, by pressing the command KW. Click on the debug icon on the left of the VS Code window. You will see an option for you to create a launch.json file. If it doesn't show, it means that the launch.json file already exists. Click on the Create a launch.json file and the VS Code will pop up a menu. There will be a few items for you to choose, and one of them is Renative. Before we click on the Renative item, let us open any index.js file and click on the Create a launch.json file option again. And you will not see the Renative option. That is the reason why I want you to close any source code window before creating the launch.json file. Now, let's remove the launch.json file we have just created. Close all source code window and click on the Create a launch.json file option again. Click on the Renative option and select all checkbox. And click on the OK button. The VS Code will generate the launch.json file. Select the Debug iOS option from the drop-down list and click on the Run button to start the debugging. The VS Code will open up the output log and show the log for starting the Metro bundle. It then will launch the app in iOS Simulator. Wait for the app to launch and the VS Code debugger to connect to the simulator. You can confirm the debugger is connected by switching to the Debug Console tab, and you will see a message indicates the connection status. Open the search index.js file in VS Code. Place 2 breakpoints in the onSearch method before and after calling getDemas. On the simulator, key in awesome again and click on the search button. The VS Code will hit the breakpoint and you can step through the app similar to what we have done on the Chrome browser. The behavior of the async method during debugging still applies in VS Code, just like in the Chrome browser. The VS Code hotkeys are different from Chrome, depending on the preference you have set. In my VS Code, F5 will continue the execution, and F10 will step over a line of code. Let's press F5 to run the app till the next breakpoint. You can see the application log the Debug Console tab. To watch the variable when stepping through the app, highlight the variable and right-click on it. Then select App to Watch from the pop-up menu. The Output tab with Renative selected allows you to see if there is any syntax error in runtime if you are modifying the source code while debugging. For example, let's continue the execution of the app by pressing F5. Now, we will modify the onSearch method by removing the async keyword and save the file. The app will reload but hit an error. The error will appear in both the simulator and output tab screen. Sometimes the simulator might not display useful information. Therefore, checking the output for Renative log will be helpful. Now, let us undo the change and save the file. The app will reload and run in the simulator again. We have completed the debugging process for VS Code. Before showing you the other ways to debug Renative app, let's stop the VS Code debugger. Click on the Stop button from the Debugger toolbox to stop debugging. We also need to click on the Stop button on the VS Code status bar to stop the Renative packages, which is the Metro bundle. Now, quit the application from the simulator. The next method to debug a Renative app is by installing third-party tools. The tool that I'm going to show you is the React Native Debugger. You can install it via the command brew update and brew cast install React Native Debugger, or just download this installer via the website as shown. Now, let's start the React Native Debugger. After the debugger tool launch, then run the JustCode DICT in the simulator. Once the JustCode DICT launch, the debugger tool will automatically connect to the JustCode DICT app. If it doesn't, make sure you have enabled the debugging in the JustCode DICT app by bring out the app developer menu and select debug menu items. The React Native Debugger tools consist of three parts. The first part is the developer tools. This is the debugging features, and it is the same debugger as using the Chrome browser. Therefore, I will not go into the debugging features. Instead, I would like to show you the second part, which is the components and profiler. We will go into detail in a short while. The last part is the Redux Dev Tools, which allow you to view the Redux state within the app. We will introduce you to Redux state in the future tutorial video. Let's close the developer tools and the Redux Dev Tool for now. On the components window, we will see a tree structure of the UI's component hierarchy. This hierarchy allows us to see the app UI layout and its properties. This is useful when we are fine-tuning the UI layout for the app. Let's bring out the developer menu in Simulator again and select Show Inspector menu item. Now, let us click on the title of the app header, and the Components window will locate the UI components for the title in the hierarchy tree. Let's click on the parent component touchable text to see the property for the title. The best thing is that we can change the property of the component on the fly without changing the source code. Let us bring out the developer menu again in the app and select Hide Inspector to turn it off. Now, I'm going to show you how to profile your app UI rendering. On the React Native Debugger, click on the Profiler tab, click on the Record button on the top left corner, and now we will try to use JustCode DICT app as per normal in the simulator. After using the app for a while, click on the same Record button to stop the profiling. The profiler will display the UI component performance readings. For example, to see the performance of the bottom tab bar, let's scroll down the profiler window till we see the bottom tab bar components and click on it. It will show that the bottom tab bar components took 0.3 milliseconds to render. We have completed with the React Native Debugger tools. Let's turn off the debugging in the simulator and close the React Native Debugger tools. Next, I'm going to show you how to debug in Flipper. Flipper is developed by Facebook and it is only for React Native Framework version 0.62 and above. To show you the usage of this tool, I had upgraded the JustCode DICT from 0.61.5, the latest version when we start this series of tutorials, to 0.62.2 as of April 2020. You can download and install Flipper from fbflipper.com. Before we start Flipper app, let's close the iOS simulator and start the JustCode DICT in Android simulator. Now, start the Flipper and you will see the Flipper will connect to the app in the simulator automatically. Even the debug option in the simulator is not turned on. The first item I want to show you is the Hamas Debugger. To use Hamas Debugger, the app needs to enable the Hamas engine, which I had demonstrated in the last tutorial. Hamas Debugger is only available for Android device, and that is the reason why we run the app in Android Simulator. Click on the Hamas Debugger item under the React Native section. This is the same debugger tools as the Chrome browser. The only difference is that this debugger works even the debug option in the app is turned off. Let's tap on the Flavor tab in the app. You will see the app log content in the Flipper console log. Now, let's click on the Source tab in the debugger. Browse to the search index.js and open the file. Place a breakpoint on the onSearch method and key in a word to search in the app. We will see the breakpoint is activated, and this shows that the debugging is working. Let's remove the breakpoint and press F8 to let the app continue to run. Since the Hamas Debugger is the same as Chrome Debugger, therefore, we will not go into details. Next is the logs below the Hamas Debugger. This is the same log content from the Metro bundle. Let's clear both Flipper and Metro bundles logs. Now, tap on the Favorite tab in the app, and we will see the helper.getFavoritList log both the terminal and Flipper screen. Followed by is the React Dev tool. This is the same React Dev tool we had shown you in the React Native Debugger tools. Next is Flipper plugins. The default plugins available for us to use are the database, image, layout, network, and share preference. The database plugin allows you to view the content of the app database, and it is only available on Android device. In our dictionary app, we use the database to store the user favorite word. Let's select the table, catalyst local storage, and we will see there is a record with the key my favorite. This is the record we use to store the user favorite word JSON string. We can see the structure of the table, perform SQL query, display table info, and show the query history. The next plugin is the Images plugin. This plugin will show all the images and their properties known by the app. It shows the size and the source of the image. Next is the Layout plugin. This plugin is very similar to the React Dev tool mentioned earlier. But instead of showing the React components, this plugin shows the native UI component and its property. The Network plugin allows you to see the network activities within your app. Let's perform a word search in the app, and you will see the network activity showing up in the list. Click on the activity in the list, and you will see the activity details like the URL, headers, and response. This plugin is useful when troubleshooting network-related issues. The last plugin is the Share Preference Viewer. This plugin allows you to see the shared preference in your app, and you even can make changes to the preference. There are other plugins in the Flipper, and I won't be able to cover all in this tutorial. You even can develop your own plugin to debug your app. Please refer to the Flipper website for more information. We have covered 4 ways to debug a React Native app. You might ask, which debugging tools should I use? I would say it all depends on your needs. For example, I would prefer VS Code if I'm debugging the app logic. This is because I can change the code while debugging, which you can't do that in the other tools. However, if I'm fine-tuning the UI or debug network issue, then I will prefer Flipper if my app is using React Native 0.62 and above. Else, I will use the third-party tool like React Native Debugger. Using Chrome browser to perform debugging is useful in a situation that you can't install any third-party tools. We have come to the end of this tutorial. I appreciate your time and effort, and I hope that you have learned from this tutorial. If you have any question regarding this tutorial, please feel free to leave a comment below. If you like our video and want to learn more about mobile app development, do support us by like our video, click on the subscribe button and the notification bell. Thanks for watching. Bye.